Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to solve linear equations, which is a topic that frequently appears in the Mathematics Knowledge Subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the PiCAT. More specifically, I'm going to be working out 20 practice problems. In order to get the most out of this video, you should pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. In all honesty, these 20 questions should take you no more than 25 to 35 minutes to work out on your own. Similarly, I want to say this. You're not permitted to use a calculator or a reference sheet on the actual ASVAB or PiCAT. So as you work your way through these practice problems, try not to use any of those resources. Finally, I want to mention this. On my YouTube channel, as well as my website, I have all the resources you need to pass the ASVAB and PiCAT. So please, please, please do not pay for tutoring. Chances are, if you pay for ASVAB tutoring or PiCAT tutoring, you're going to get nothing more than a rehash of what's freely available on my channel already. So all that being said, let's go ahead and get started with today's video. All right, so before we get started with the first practice problem, I just want to mention a few things. Feel free to skip over this part of the video if you're confident in your ability to solve equations already. But that said, I want to mention these two things. The goal of solving linear equations is to find the value of the variable that will make the statement, that is the equation, true. And what are true mathematical statements? 5 equals 5. That is a true statement. 5 does in fact equal 5. What about 0 equals 2? Well, of course that's not a true statement. 0 does not equal 2. When I work out the first problem in this video, I'm going to show you an example of checking to see whether our solution makes a true mathematical statement or not. In addition, we have to realize this. In order to reach our goal, we're going to have to perform operations, that is addition, subtraction, multiplication, and division, to one or both sides of the equation in order to isolate our variable. Now, as far as variables go, I don't want you to get used to just using x as a variable. In mathematics, variables can be everything from A to Z. More often than not, people use X and Y, but if you see A, B, or C, those are variables. All right, so finally, I just want to say this. In my experience, the only way you can really get good at solving linear equations is actually to work out practice problems. So with those two things in mind, let's go ahead and quickly work our way through these 20 practice questions. All right, so as we can see, number 1 here says 4x equals 4. And remember, our goal is to find a value of x such that this equation is true. And so let's get started by copying this one off to the side. We have 4x equals 4. And now we have to refer to our method. Our method says use addition, subtraction, multiplication, and division in order to isolate your variable. That is to get your variable by itself. So in other words, when we're done with this one, we're going to have x equal to something by itself. So the first thing we want to do here is divide both sides by 4. This crosses out here, leaving you with just x on this side. 4 divided by 4 is 1. All right, so we are pretty much done with this one. We said x equals 1. Now, is there a way we can check to see if x equal 1 makes this equation true? We can. We can quickly check our work if we really wanted to. First, I'm going to copy down our original equation. 4x equals 4. Again, we said to let x equal 1 in order to make this a true mathematical statement. So instead of x here, I'm going to replace that with 1. So this becomes 4 times 1 equals 4. 4 times 1 is 4, and we're left with 4 equals 4. Does 4 equal 4? Is that a true mathematical statement? It is. Therefore, we know x equals 1 is the correct solution to this equation. All right, so number 2 says x plus 6 equals negative 7. Not surprisingly, I'm going to get started by copying this one off to the side. We have x plus 6 equals negative 7. And remember, our goal is to find a value of x that makes this equation true. And our method says to use addition, subtraction, multiplication, and division in order to isolate our variable. So again, uh, we know we're going to be done solving this one when we get x equal to something by itself. So in this case, what we're going to do is move this 6 to the other side of the equation by subtracting it from both sides. This crosses out, leaving you with just x on this side. Negative 7 minus 6 is negative 13. All right, so we are technically done with this one. But as I just said, if you're unsure as to whether negative 13 makes this equation true, you can always quickly check your work. And again, copy over the original equation, x plus 6 equals negative 7. Again, we know x has to be negative 13. So let's plug in negative 13 for x. This becomes negative 13 plus 6 equals negative 7. Negative 13 plus 6 is negative 7. And does negative 7 equal negative 7? It does. So we know that's a true mathematical statement. And therefore, I can say with great confidence that x does in fact equal negative 13. All right, so as we can see, number 3 says 10 minus x equals 6. We have 10 minus x equals 6. Again, our goal is to find a value of x such that this becomes a true equation. And according to our method, we're going to use addition, subtraction, multiplication, and division in order to isolate our letter variable. That means we're going to get x equal to something by itself. When we get that, we know we've solved this equation. All right, so let's start by subtracting 10 from both sides in this case. This crosses out here, leaving you with negative x over here equals 6 minus 10. Well, 6 minus 10 is negative 4. All right, so we're not quite at the point where we have x equal to something. Instead, we have negative x equal to something. And in case it's not obvious, there's technically a negative 1 in front of this x. So we have negative 1x equal to something. Well, how can we make this become a positive? What if we divide both sides by negative 1? This crosses out here and here, leaving you with x. And what's negative 4 divided by negative 1? A negative divided by a negative is going to be a positive. So this is going to be positive 4. And again, we're at the point where we have x equal to something. So technically we're done. That said, I still want to check our answers for these first few problems until we get the hang of them. Again, let's go ahead and quickly check our work. Let's copy over the original equation. Again, the original equation was 10 minus x equals 6. We now know that x should be 4 if we did our work correctly. So let's go ahead and put 4 in for x. This becomes 10 minus 4 equals 6. 10 minus 4 is 6. Does 6 equal 6? Yes, that's a true mathematical statement. Therefore, I'm confident that x does in fact equal 4. All right, so as we can see, number 4 says x over 3 equals negative 9. So let's go ahead and copy this one off to the side. We have x over 3 equals negative 9. Remember, our goal is to find a value of x that makes this equation true. And according to our method, we're going to use addition, subtraction, multiplication, and division in order to do so. What's more, our method says we want to isolate our letter variable. That is, we want to get our letter variable equal to something by itself. So in this case, we'll know we're done when we have x equal to something by itself like that. Now, this problem's pretty tricky. Again, the way I view this problem is like this. I have an imaginary 1 in front of this x. Again, in algebra, 1s are typically not placed in front of letter variables. So you can place that in there if it helps. And then you can actually rewrite this to be 1 over 3 times x equals negative 9. Now, We just have to get rid of this 1/3 in front of this x. And the way we're going to do that is we're going to multiply 1/3 by its reciprocal, which is 3 over 1. And we're going to do that to this side of the equation as well. So again, this is going to cancel out here and here, leaving you with just x on this side. So we're very close to having this. That said, we still have to work out this side of the equation. We have -9 times 3 over 1. Well, what is 3 over 1? 3 over 1 is the same thing as 3 divided by 1, and anything divided by 1 is just itself. So 3 divided by 1 is just 3. So this becomes -9 times 3. We should know that a negative times a positive is going to be a negative. So -9 times +3 is going to be negative. 9 times 3 is 27. All right, so technically we're done with this one. And if you're confident your answer is correct, you can go ahead and move on. That said, it's very easy to check your answers. So let's go ahead and do that in this case. Again, I'm going to start by copying the original equation over here. We have x over 3 equals -9. Again, if we did our work correctly, we know x should equal -27. So in place of x, let's go ahead and plug in -27. This becomes -27 over 3 equals -9. Negative divided by a positive is going to be a negative. -27 divided by 3 is 9. Does -9 equal -9? It does. That's a true mathematical statement. So I'm very confident that x does in fact equal -27. All right, so as I keep saying, you don't have to check your work. If you're confident you got it correct, you can go ahead and move on. All right, so number 5 here says 8x minus 3 equals -19. Again, our goal is to find a value of x such that this equation becomes true mathematically. And according to our method, we're going to use addition, subtraction, multiplication, and division as needed in order to isolate our letter variable. In other words, we want to get x in this case equal to something by itself. All right, so the first thing I'm going to do in this problem is add 3 to both sides. And as you can see, that's going to get 8x equal to something by itself. And then this becomes -19 plus 3, which is -16. And finally, to get x by itself, we can divide both sides by 8. This crosses out, leaving you with x. -16 divided by 8 is going to be -2. Again, a negative divided by a positive is negative. And of course, we're still working out some simple problems, so let's go ahead and quickly check our work. That said, if you're confident that you solved this one correctly, you don't have to do that. So we have 8x minus 3 equals -19. Again, if we did our math correctly, we know x should be -2. So let's go ahead and plug in -2 where we see x. So this becomes 8 times -2 minus 3 equals -19. 8 times -2 is -16 minus 3 equals -19. -16 minus 3 is -16, 17, 18, 19. So this is -19 equals -19. Is that a true mathematical statement? It is. Therefore, I'm very confident that x does in fact equal 2 in this case. All right, so as we can see, number 6 says -x equals -12. So let's go ahead and copy that one off to the side. We have -x equaling -12. Again, our goal is to find a value of x such that this is a true mathematical statement. That said, our method says to use addition, subtraction, multiplication, division in order to isolate your letter variable. That is to say, in this case, we want to get x equal to something by itself. And once we achieve that, we know we're done. And in this case, we're very close to having x equal to something by itself. That said, we have this negative in front of this x. So let's see how we're going to deal with that. And in a problem that I've already worked out, we've dealt with that. Again, in algebra, ones are typically not expressed in front of letter variables. That said, it can be helpful to temporarily write that one in there. So I can write this as -1x. equals negative 12. And now it's very obvious that in order to solve for just x here, we can divide both sides by negative 1. This crosses out here, leaving you with x equals, and what does x equal? It equals negative 12 divided by negative 1. A negative divided by a negative is a positive, and as I said, anything divided by 1 is just itself, so this is just 12. All right, so as you can see, we now have x equal to something by itself. Of course, we can quickly check our work if we want. And to start, we're just going to copy this expression over here. We have negative x equals negative 12. We now know that x should be 12. So let's go ahead and plug in 12 for x. This becomes negative 12 equals negative 12. Is that a true mathematical statement? It is. And in light of that, I'm very confident that x does in fact equal 12. All right, so a very simple problem there. All right, so number 7, as you can see, says negative 9x minus 9x equals negative 9. So let's copy this off to the side here. We have negative 9x minus 9x equals negative 9. All right, so again, our goal says to find a value of x such that we create a true equation. And similarly, our method says isolate your letter variable by performing addition, subtraction, multiplication, and division. In other words, in this case, we want to get x equal to something by itself. And once we do that, we know we're done, assuming we did our math correctly. All right, so in this case, the challenging aspect of this problem is the fact that we have a pair of like terms. Negative 9x and negative 9x are like terms. And if you watch my video on like terms, you'd know that you can combine these two into a single term. Negative 9x minus 9x is negative 18x. Of course, that equals negative 9. Now, as far as solving this equation for x goes, it's very, very easy to do. We're just going to divide both sides by negative 18. And in doing so, this crosses out here, leaving you with x on this side. And as we can see, we have a negative divided by a negative. So I know this is going to be positive 9 over 18. That said, we should also see that we can simplify our answer, and chances are you'll have to do this for the ASVAB, by dividing our numerator, that is 9, as well as our denominator, that is 18, by a common factor of 9. 9 divided by 9 is 1. 18 divided by 9 is 2. So x in this case is 1/2. So at this point, if you're confident you did your work correctly, you would be done. That said, I want to show you how to check this one because it's not necessarily that easy. Let's go ahead and check our work here. All right, so we have the equation negative 9x minus 9x equaling negative 9. And we know x has to be 1/2, right? So in place of x in our equation, let's go ahead and substitute 1/2 in here as well as here. This becomes negative 9 times 1/2 minus 9 times 1/2 equals negative 9. Well, what is 1/2 of 9? It's 4.5. So this becomes negative 4.5. And my pen's starting to act up here, of course. Negative 4.5 minus 4.5 equals negative 9. Negative 4.5 minus 4.5 is negative 9. And we have negative 9 equals negative 9. Is that a true mathematical statement? It is. Negative 9 does in fact equal negative 9. Therefore, I'm very confident that x does in fact equal 1/2. So our solution to this one is x equals 1/2. All right, so that's that one. All right, so as you can see, number 8 says 3 times x minus 2 in parentheses equals 6. So we have 3 times x minus 2 in parentheses equals 6. All right, remember, our goal is to find a value of x such that this equation becomes true. And according to our method, we're going to use addition, subtraction, multiplication, and division. in order to isolate our letter variable. So in this case, we're going to get x equal to something by itself. And once we do that, we'll know we're done with this one. So I'll try to slow down my speaking as I solve this one. But that said, to get started with this one, we're going to take this 3 and we're going to use the distributive property and take this 3 and multiply it here as well as here. So this becomes 3 times x and then 3 times negative 2. Well, 3 times negative 2 is negative 6. So this is 3 times x minus 6 equals 6. And now we have an equation that we've seen in this video already. We're just going to add 6 to both sides now. This crosses out here, leaving you with 3x on this side. As we can see, 3x is equal to 6 plus 6, which is 12. Let's divide both sides by 3 now. This crosses out, leaving you with x. What is 12 divided by 3? That is 4. All right, so again, we've solved this equation. That said, if you're not sure about your answer, you can always quickly check your work. Again, if you're taking the actual test, I would only check your work if you're unsure as to whether you solved it correctly. So we have 3 times x minus 2 equals 6. And we know that if we did our work correctly, x should equal 4. So let's take 4 and plug it into this equation here. So we have 3. My pen is starting to act up here. Just bear with me. 3 times 4 minus 2 equals 6. Again, according to the order of operations, you work out what's in parentheses first. So we're going to do 4 minus 2 first. 4 minus 2, of course, is 2. So this becomes 3 times 2 equals 6. 3 times 2 is 6. Does 6 equal 6? It does. And therefore, I'm very confident that x does in fact equal 4 and we did our work correctly. All right, so that's that one. Let's keep the ball rolling here. So once we get past number 10, I'm going to start picking things up quite a bit. So number 9, as you can see, says negative 3 times 2x minus 8 in parentheses equals negative 12. So again, we have negative 3 times 2x minus 8 equals negative 12. Again, our goal is to find a value of x such that this equation is true. And what's more, we're going to use addition, subtraction, multiplication, and division in order to isolate our letter variable. In this case, our letter variable is x, so we know we're done solving this one when we have x equal to something by itself. And as we saw in the previous problem, we're going to get started by taking this negative 3 and distributing it here as well as here. Negative 3 times 2x is negative 6x. Negative 3 times negative 8. A negative times a negative is a positive. Therefore, negative 3 times negative 8 is positive 24. This equals negative 12. All right, so now we have something that's very easy to work with. So let's continue working this one out by subtracting 24 from both sides. This crosses out, leaving you with negative 6x here. Negative 12 minus 24 is going to be negative 36. And now to get x by itself, we're going to divide both sides by negative 6. This crosses out, leaving you with x here. A negative divided by a negative is going to be a positive. Negative 36 divided by negative 6 is going to be positive 6. All right, so we're done. We solved this equation. That said, if you're ever unsure, you can quickly check your work. And let's go ahead and do that. Again, our original equation was negative 3 times 2x minus 8 in parentheses equals negative 12. And we were told that, or we figured out that x has to equal 6. So in place of x in our equation, we'll go ahead and plug in 6. So this becomes negative 3, 2 times 6 minus 8 equals negative 12. All right, so according to the order of operations, we do what's in parentheses first. What's more, according to the order of operations, we do multiplication before subtraction. So this becomes negative 3. 2 times 6 is going to be 12, so this is 12 minus 8 equals negative 12. 12 minus 8 is going to be 4. So this is 3 times 4 equals negative 12. Negative 3 times 4 is negative 12. Does negative 12 equal negative 12? Yes, it does. That's a true mathematical statement. Therefore, I know x has to equal 6. All right, so we are done with that one. All right, so for number 10, you can see we have 3x plus 2x plus 6 equals negative 15. So let's get this one copied off to the side. And that's 3x plus 2x plus 6 equals negative 15. Again, as these equations get long, you want to take your time copying them onto your scratch paper, because I guarantee you someone watching this video is going to say, oh, I got that one right, but he got it wrong. No, you probably copied it down wrong. So be careful as you do that. Um, Again, our goal is to find a value of x such that this equation becomes true. And remember, our method says to use addition, subtraction, multiplication, and division as needed to isolate your letter variable, which means that we want to get x equal to something by itself in this case. All right, so let's go ahead and work on doing that for this problem. We should see right away that 3x and 2x are like terms, and in light of that, we can combine them. 3x plus 2x is 5x, so this becomes 5x plus 6 equals negative 15. All right, so let's go ahead and keep solving this one. Let's subtract 6 from both sides now. This crosses out, so leaving us with 5x equals negative 15 minus 6 is negative 21. And finally, let's divide both sides by 5 now to get x by itself. This crosses out here, leaving you with x equals negative 21 over 5. All right, so I'm not going to plug that one in to check this. That would take a lot of work. I'm fairly confident I solved this one correctly. That said, I will say this. Again, the ASVAB is a multiple choice test. So if you don't see negative 21 over 5, for instance, as an answer choice, you have to realize that negative 21 over 5 is an improper fraction, which means that you can convert it to a mixed number by performing this long division here. Again, we have a negative divided by a positive, so we know our answer is going to be negative. And now that I've accounted for the negative in our answer, I want to convert this to a mixed number. And in order to do that, I'm just going to read this as long division. This says 21 divided by 5. And we start by asking ourselves, how many times does 5 go into 2? It doesn't. How many times does 5 go into 20 without going over? Well, that's 4 times. 4 times 5 is 20. 21 minus 20 is 1. And now we have enough to write our mixed number. This 4 is going to be our whole number. This 1 is going to be our numerator. And this 5 is going to be our denominator. All right, so again, sometimes when you're taking the ASVAB, you'll solve a question and you won't see your answer there among the answer choices, in which case you may have to convert your answer to an improper fraction, to a mixed number, or even to a decimal or percent. So just keep that in mind as you get ready to take that test. All right, so number 11 says 2 times x plus 7 in parentheses equals 6x plus 9 minus 4x. Let's start by copying this one down. Again, we have 2 times x plus 7 equals 6x plus 9 minus 4x. Remember, we first have to take this 2 according to the distributive property and multiply it here as well as here. So this becomes 2 times x, which is 2x. 2 times 7, which is 14, equals 6x plus 9 minus 4x. Now you should see that we have x's all over the place in this equation. We have a 2x over here, a 6x here, and a negative 4x here. So I'm going to try to consolidate my x's at this point. And what I'm going to do more specifically is I'm going to combine 6x and negative 4x since those are like terms. 6x minus 4x is going to be 2x, so this becomes 2x plus 9. And then over here we have 2x plus 14. All right, so again, remember, we want to isolate our x variable. And in this case, we can do that by moving 14 to this side via subtraction. And at the same time, we can move 2x to this side via subtraction. 14 minus 14 is nothing. 2x minus 2x, that is 0. 2x minus 2x is nothing. And now we have 9 minus 14, which is negative 5. Well, remember what I said. If in solving your equation, you're left with something that's an untrue mathematical statement, then you know that there's going to be no solution. All right. In other words, there's no value of x that you could ever plug into this equation to make this a true statement. All right. So again, this one has no solution. All right. So as we can see, number 12 says 2 times x plus 4 in parentheses equals negative 3 times x plus 5 in parentheses. Let's go ahead and copy this one off to the side here. We have 2 times x plus 4 equals negative 3 times x plus 5. Again, our goal is to find a value of x such that we make this equation true. What's more, we're going to use addition, subtraction, multiplication, and division in order to isolate our letter variable, which means in this case, we're going to be solving for x. That is, we want to get x equal to something by itself, and when we do that, we'll know we're done with this one. All right, so in this case, we're going to have to use 2 instances of the distributive property. We're going to use one instance here to take this 2 and multiply it by this x, as well as this 4. Then we're going to take this negative 3, multiply it by this x, as well as this 5. So let's go ahead and work that out. This becomes 2 times x, which is 2x, plus 2 times 4, which is 8, equals negative 3 times x, which is negative 3x, minus, and how do I know it's minus? We have negative 3 times positive 5. A negative times a positive is going to be a negative. Negative 3 times positive 5 is negative 15. All right, so again, our goal is to isolate our letter variable x. So I'm going to take this one step at a time. I'm going to subtract 8 from both sides. This crosses out, leaving you with 2x over here equals negative 3x. Negative 15 minus 8. Well, if this was negative 16 minus 8, this would be negative 24. So I know that this is going to be negative 23. All right, so let's go ahead and move this 3x to this other x via addition. This crosses out, leaving you with negative 23 over here. 2x plus 3x is 5x. Again, we want to get x equal to something by itself. So we're going to divide both sides by 5. This crosses out, leaving you with x equals negative 23 over 5. All right, so the answer to this one is negative 23 over 5. If you wanted to, you can plug that value in to check your work. That said, at this point in the video, I'm not going to be doing that. All right, so as you can see, number 13 says x minus 3/4 equals negative 2x. We have x minus 3 over 4 equals negative 2x. All right, so again, our goal is to find a value of x such that this becomes a true statement. What's more, we're going to use addition, subtraction, multiplication, and division in order to isolate our letter variable. In other words, we want to get x equal to something, and once we do that, we'll be done with this one. All right, so in this case, it's actually going to be easier to move this x to be with this negative 2x via subtraction. So let's subtract x from both sides here. This crosses out, leaving you with negative 3 over 4 equals. What's negative 2x minus x? Of course, that's negative 3x. And now we have to get x by itself, and we're going to do that by dividing both sides by negative 3. This crosses out, leaving you with just x on this side. Now, I'm going to work this off to the side. We have negative 3/4 over negative 3. That is to say, we're dividing a fraction by a whole number. Well, in reality, we're dividing a fraction by another fraction because I can write -3 as a fraction by placing it over 1. And when you divide two fractions, you follow the algorithm keep, change, flip to solve it. And in this case, this becomes this. Again, keep, change, flip. The k refers to this first fraction in the numerator. We keep that the same, -3/4. It stays the same. This change refers to this division bar here. We change that from division to multiplication. And this flip refers to the fraction in the denominator. Instead of being -3/1, we're going to flip it such that it becomes -1/3. And now, as you probably know, multiplying fractions is very, very easy. You just multiply straight across. And again, this is -3/4 times -1/3. So we know we have a negative times a negative. Our answer is going to be positive. 3 times 1 is 3. Uh, 4 times 3 is 12. Okay, we're not quite done yet. Again, we can simplify this a little bit further by dividing our numerator and our denominator by a common factor of 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So -3/4 divided by -3 is going to be 1/4. And of course, in math, it's customary to write the variable for which you solved on the left. So this becomes x equals 1/4. All right, so that is that one. All right, so as we can see, number 14 says x/4 minus x/6 equals 1/4. All right, so we have x/4 minus x/6 equals 1/4. And as you can see, this problem is going to require us to work with fractions, which I know are your favorite thing to work with. So I'm looking forward to this one too. Again, our goal is to find a value of x such that this equation makes a true statement. And in order to accomplish that, we're going to use addition, subtraction, multiplication, and division to isolate our letter variable. That is to say, we're going to get x equal to something by itself when we're done. So um, remember how I said that in algebra, you typically don't express ones in front of letter variables? Well, in this case, it's going to be very, very helpful to do so. So I'm going to put my 1 there and my 1 there, and then I'm going to rewrite this as 1/4 x minus 1/6 x equals 1/4. All right, so uh, 1/4 x and 1/6 x are actually like terms, so we can combine them. That said, they have coefficients of 1/4 and 1/6, and those are fractions. So before we can combine our like terms in this problem, we actually have to rewrite either one or both of these fractions such that they have a common or the same denominator. And we should see that both 6 and 4 go into 12. So I'm going to rewrite both these fractions such that they're going to be over 12. All right, so let's go ahead and work on doing that. In order to write 4 as 12, I'd have to multiply it by 3, given that 3 times 4 is 12. I'll also have to do that to its numerator. 3 times 1 is 3. So 1/4 is the same thing as 3/12. In order to write 6 as 12, I would have to multiply it by 2. I'm also going to do that to its numerator. 6 times 2 is 12. 1 times 2 is 2. All right, now that these like terms have the same fractions as coefficients, we can simply subtract this. 3/12 minus 2/12 is 1/12. X equals 1/4. All right, and now we just got to get rid of this 1/12 in front of this x. And to do that, we're going to multiply both sides by 12/1. This crosses out here and here, leaving you with just x. And let me just say this. When you multiply fractions, you're doing nothing more than multiplying straight across. So this becomes 1 times 12, which is 12, over 4 times 1, which is 4. Well, what is 12 divided by 4? It's 3. All right, so the answer to this one is x equals 3. All right, so as you can see, number 15 says 1 over 7x equals 2. So we have 1 over 7x equals 2. Again, our goal is to find a value of x such that this becomes a true statement. What's more, we're going to use addition, subtraction, multiplication, and division in order to isolate our letter variable. In other words, we want to get x equal to something in this case. All right, so uh, this one should be pretty easy to solve since we've worked out very similar things in this video already. Again, our goal is to get x by itself, so we got to get rid of this coefficient of 1 over 7, which means we're going to multiply it by its reciprocal, notably 7 over 1. We have to do that to both sides. This crosses out here and here, leaving you with just x over there. And again, let's think about this one this way. We have 2 times 7 over 1. Well, what is 7 over 1? That's 7 divided by 1. Anything divided by 1 is itself, so this is 2 times 7. Of course, 2 times 7 is 14. All right, so that's that one. Pretty easy one. All right, so number 16 says 6 over 5x equals 90. So let's go ahead and copy this one down. We have 6 over 5x equals 90. And again, our goal is to find a value of x such that this equation becomes true. And in order to do that, we're going to use addition, subtraction, multiplication, division in an effort to isolate our letter variable. In other words, we want to get x equal to something by itself. As we've seen previously, what we're going to do is we're going to make an effort to get rid of this fraction in front of this x. And to do that more specifically, we're going to multiply this fraction by its reciprocal, notably 5 over 6. And we're going to do that to both sides of the equation. This crosses out here and here, leaving you with just x there. And now we have 90 times 5/6. I'm going to go ahead and work this off to the side since this is pretty difficult to do in my opinion. We have 90 times 5 over 6. Well, as it happens, you can write whole numbers, any whole number, as a fraction by placing it over 1. And now we're just multiplying two fractions, so we could just multiply straight across. This becomes 90 times 5 over 1 times 6. Well, what is 90 times 5? 9 times 5 would be 45. Therefore, 90 times 5 is 450. And what is 1 times 6? 1 times 6 is 6. Now, are we done? I don't believe we are, since I believe 450 is divisible by 6. So let's try this long division here. What is 450 divided by 6? Well, we start by asking ourselves, how many times does 6 go into 4? It doesn't. How many times does 6 go into 45 without going over? That's going to be 7 times. 6 times 7 is 42. 45 minus 42 is 3. And now we drop down this 0. How many times does 6 go into 30? That's going to be 5 times. 6 times 5 is 30 with no remainder. So we can see that 450 over 6 is 75. In other words, 5/6 times 90 is 75. All right, so that's that one. All right, so number 17 here says negative 4/9 x equals negative 36. So let's go ahead and copy this one off to the side here. We have negative 4 over 9x equals negative 36. All right, so again, our goal is to find a value of x such that this equation becomes true. In addition, we want to use addition, subtraction, multiplication, and division in an effort to isolate our letter variable, which means we want to get x equal to something in this case. All right, so this one's pretty simple. We want to get rid of this negative 4/9 in front of this x, which will get x by itself. And to do that, we can multiply negative 4/9 by its reciprocal, which is negative 9 over 4. And we have to do that to both sides of the equation. This crosses out here and here, leaving you with just x on this side. And this is where people will probably get lost. So let me take this and work it off to the side here. We have negative 36 times negative 9 over 4. Well, as I keep saying, you can represent all whole numbers as fractions by placing them over 1. So this is the same thing as negative 36 over 1 times negative 9 over 4. And if you want to keep things simple, you could also say this. 4 goes into 4 one time, 4 goes into 36 9 times. So uh, in doing so, you're left with this, negative 9 over 1 times negative 9 over 1. Well, negative 9 divided by 1 is just negative 9, and negative 9 divided by 1 is just negative 9. What is negative 9 times negative 9? Negative times a negative is a positive. 9 times 9 is 81. So x in this case is 81. Number 18 is similar to the last problem. As you can see, it says 5 over 9y minus 4 equals 6. So we have 5 over 9 y minus 4 equals 6. Again, our goal is to find a value of y that makes this equation true, and we're going to use addition, subtraction, multiplication, and division in an effort to isolate a letter variable. So that means we're going to use those operations ultimately to get y equal something by itself. All right, so prior to dealing with this fraction in front of our y, we can actually go ahead and add 4 to both sides. This crosses out here, leaving you with 5 over 9 y equals 6 plus 4, which is 10. All right, so this is very, very similar to what we just saw previously. Again, to get rid of this fraction in front of this y, we're going to multiply it by its reciprocal, notably 9 over 5. We're going to do that to both sides of the equation. This crosses out here and here, leaving you with y on this side. And now we got to deal with this. We have 10 times 9 over 5. Well, as you just saw, we can actually represent this 10 as a fraction by placing it over 1. So this is 10 over 1 times 9 over 5. And if we want to keep the math very, very easy, we can say 5 goes into 5 one time, 5 goes into 10 two times. So now we have 2 over 1, which is 2, times 9 over 1, which is 9. 9 times 2 is 18. So y in this case is going to be 18. All right, we got 2 more to go. And as we can see, number 19 here says x over 3 minus x over 5 equals 2. So let's copy this one down. We have x over 3 minus x over 5 equaling 2. Again, it's going to be helpful to express these ones in front of these x's because that's going to enable you, as you've seen in this video already, to rewrite these like this: 1 over 3x minus 1 over 5x equals 2. And as it happens, 1 over 3x and 1 over 5x are like terms, and therefore we can combine them. That said, since they have coefficients, that is, the numbers in front of them are fractions, we actually have to do some work before we can combine them. More specifically, we're going to have to either write one or both of these fractions such that they have a common denominator. Well, we see our denominators are 3 and 5, and it should be pretty obvious that a common denominator between 3 and 5 would be 15. So let's go ahead and rewrite these such that they have denominators of 15. In order to write 3 as 15, I would have to multiply it by 5. Also going to have to do that to its numerator. 5 times 3 is 15. 5 times 1 is 5. To write 5 as 15, I would have to multiply it by 3. And I also have to do it to its numerator. 1 times 3 is 3. So this becomes 15 over 5x minus 3 over 15x. And now we can combine those. Again, we're just subtracting fractions here. So this is going to be 2 over 15x equals 2. All right, now we have something very similar to what we've worked out in the last few problems now. And to get rid of this coefficient of 2 over 15 in front of this x, we're going to multiply it by its reciprocal, notably 15 over 2. And we're going to do that to both sides of our equation here, 15 over 2. This crosses out here and here, leaving you with just x on this side. And now we got to take care of this. And I'm going to do that off to the side here. We have 2 times 15 over 2. Again, I could write 2 as a fraction by placing it over 1. And I can actually reduce this very quickly. I could say 2 goes into 2 one time, 2 goes into 2 one time. So this becomes 1 over 1, which is just 1, times 15 over 1, which is just 15. 1 times 15 is just 15. So x is 15 in this case. And we are done with that one. All right, so we've made it to the final problem in this video. And to reward you for that, uh, I chose to include a problem that involves some fractions here. So as we can see, number 20 says a minus a over 3 plus a over 5 equals 26. So we have a minus a over 3 plus a over 5 equals 26. Again, our goal is to find a value of a such that this equation is true, and we're going to use addition, subtraction, multiplication, and division in an effort to isolate our letter variable. In other words, we want to get a equal to something by itself when everything's said and done. So let's go ahead and work on applying our principles that we know about algebra and fractions to set this one up correctly. Again, if it's helpful, you can write those ones in front of our a's here. And that's going to enable us to rewrite this one like this. A minus 1 over 3a plus 1 over 5a equals 26. Okay? Now, 1 over 3a, and 1 over 5a are like terms, so we can combine them. That said, it's not very obvious if a is a fraction. Well, it is. Again, there's technically a 1 in front of this a, and we can write all whole numbers and even whole numbers and letter variables as fractions by placing them over 1. So that's what that would look like as a fraction. And in light of that, we're going to have to find a common denominator between 1, 3, and 5 to rewrite all of these such that they have the same denominator, which will enable us to combine our like terms and ultimately solve for a. So what is the common factor of 1, 3, and 5? Well, of course, that's going to be 15. So we're going to be rewriting all of these such that they have, and that's subtraction, don't make a mistake this far in the video, such that they have denominators of 15. Okay. That's actually pretty easy to do. To write 1 as 15, we would multiply it by 15. We're also going to do that to its numerator. 1 times 15 is 15. 1 times 15 is 15. Okay, so we can see that 1a is the same thing as 15 over 15a. To write 3 as 15, we're going to multiply it by 5. We're also going to do that to its numerator. 3 times 5 is 15. 1 times 5 is 5. To write 5 as 15, we have to multiply it by 3. We're also going to do that to its numerator. 5 times 3 is 15. 1 times 3 is 3. All right, so now that we've rewritten these such that they all have the same denominators, let's go ahead and combine our like terms. Again, all these a's are like terms. So we have 15 over 15a minus 5 over 15a plus 3 over 15a. And since this is a little bit complicated, I'm going to do this one like this. Again, we're subtracting and adding fractions. So we're going to do this. 15 minus 5 plus 3a equals 26. All right. And let's go ahead and work this out. 15 minus 5 is going to be 10. 10 plus 3 is 13. So this is 13 over 15. A equals 26. Again, we've seen this part of this problem already. We want to clear this fraction in front of our letter variable. So we're going to multiply this fraction by its reciprocal, notably by 15 over 13. And we're going to do that to both sides of our equation here. This crosses out here and here, leaving us with a. So we're almost there. We've almost solved this one. And I'm going to work this off to the side in case you can't see it. We have 26 times 15 over 13. Again, I can write 26 as a fraction by placing it over 1. And then instead of doing all this work, I can say this. 13 goes into 13 one time, 13 goes into 26 two times. So what do we have here? We have 2 over 1. 2 divided by 1 is just 2. 15 times 15 over 1. 15 over 1 is just 15. 2 times 15 is 30. So A in this case is 30. All right, so that's that one. All right, so that is it for this video. As usual, I hope you found it very helpful. And as always, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider becoming a subscriber. I always appreciate that very much. And on that note, I'm going to go ahead and cut you loose.